This morning I will be giving the point of view of science. So if it turns out there are no angels in our universe, if auras are not real, if reincarnation is not real, there's still enough to truly inspire us that our universe is vast and varied, and modern science has established this almost beyond doubt. What is science? What is this field that I'm speaking for? The one key is that it is all based on experiment, that we can always reproduce the same results for everyone. And science as a field is open to everyone, any religion or lack of religion, any national origin. The key is that the publicly available experiments should be of equal ability to convince anyone. So something like a revelation that you have, it might be important. There are other aspects of human experience besides science, but that will be the realm of religion or New Age studies. Imagine that you had never left the city of Atlanta. You'd lived all your life here. You would have very limited experiences, and your ideas would also be limited. When we have new experiences beyond what we are used to, we can be surprised. Our imagination is not as rich as nature, as what is out there. So if you'd never left Atlanta and everyone you knew had always lived in Atlanta, you wouldn't know, say, about time zones. You wouldn't know that when it's noon here, on the other side of the world it's midnight. In the southern hemisphere, the seasons are reversed. In the Arctic Circle, the sun doesn't rise and set every day. So these would blow your mind. You would return to Atlanta after a trip around the world, speaking in what would seem to be a mystical language. It can be noon at midnight and midnight at noon. That would make no sense to your friends back home. And that's what we have in science, that we had limited experience before, and all our traditions are based on what the experiences that were available to us. And as we widen our experiences, we widen our possible ideas. So, for example, speed of light. When you start to move near the speed of light, you have a whole new range of experiences that we now explain using the theory of relativity. When you fall into a black hole, and I really hope nobody here does fall into a black hole, it's really bad. You kind of get stretched apart by the gravity, tidal force, and it's called spaghettification. You're stretched like a strand of spaghetti until you snap, and each piece snaps, and yuck. Don't fall into a black hole. You're never going to get out, and it's not much fun. You can't share a picture on Snapchat or Instagram anyway. So yeah, stay away, bad news, falling into black holes. But if you did get near one, you would notice that space and time can get stretched. They can be curved. And this is an example of the general theory of relativity. And all our common sense notions have to be put aside because very careful experiments show that this theory is true. Now, the quantum world. Some of you might have seen the recent movie, the Captain America movie, that has this character in it called Ant-Man. He can squeeze down to the size of an ant. If he went further, if he were Atom Man or Electron Man, he would experience weird things that come from the theory of quantum mechanics, or rather the theory of quantum mechanics was born to make sense out of those weird experiences that we had in our experiments. So my caution is to be very careful about incorporating quantum mechanics into your picture of the world. As it's been filtered through the New Age movement, it's kind of lost track of some of the very important details. It's true that quantum mechanics, to appreciate it, probably requires kind of a mystic mindset. After all, saying noon is midnight on another part of the world also requires a step of imagination, almost mystical. So quantum mechanics, does it say, for example, that perception influences reality? Yes, in many ways, and yet you wouldn't want to put on blindfolds and walk out into the middle of traffic. Just because you didn't see those cars didn't mean they weren't there. So you have to be careful about how this theory applies to different areas of life. The theories were all developed to explain experiments. In one experiment, beams of light of different color were shining on a metal, and electricity, a current flowed out of that metal depending on the color, but not the brightness. Another experiment had beams of silver atoms that passed through a magnetic field, north and south, that split up that beam into two beams. And then you had other beams, other magnetic fields that would split up the beam further. And that could only be explained by making this new theory of quantum mechanics. Another approach, another experiment, we took beams of electrons, and those were shining on a nickel crystal, and the electrons bounced back at only certain angles. Also the spectrum, you take a prism, and you have a neon light shine through that prism, only certain colors make up the spectrum of that neon light. So imagine that you went back in time to the people doing this experiment and you told them, hey, perception influences reality. Would that lead them to this great big breakthrough of quantum mechanics? Probably not. There's a lot more to quantum mechanics than the ideas that have filtered through to the common consciousness. So these people doing the experiments would explain them based on math in which A times B is not B times A. That expresses that the order in which you observe things matter because your observations do affect what happens. But it doesn't make common sense to us based on our usual ideas of multiplication. You'd be using the square root of -1 to explain these experiments. And maybe the most crucial thing is that at the end of the day, when we have this theory with all this math to explain this experiment, we don't really know what it means, even among scientists. Scientists who've studied a lot of philosophy and religion, Buddhist studies, they all have different ideas of what it all means. So in some ways you can pick and choose, but I have to caution also against something that theologians and scientists also caution against, called the God of the gaps. It's not a good idea to take an area of science that we currently don't understand and claim this now will always be the realm of religion or New Age studies, because science will advance and maybe someday we will have an explanation for that. Maybe of all these different ways of looking at quantum mechanics, someday we'll find that one of them explains an experiment better, and then the scientific community will accept that. So caution to be careful. Maybe someday we'll understand where the Big Bang came from. We don't now. Maybe someday we will. So what mysteries do I think are really spiritually inducive of growth? Science really, in many ways, is a spiritual approach to the world, with its main spiritual touchstone being the idea of openness to experience. So that itself is spiritual in science in its approach. The results that we found, we are still in search of a theory of everything. In science, we are always provisional. We don't say we know everything now. We have a process of growth, and that's called comparing with experiment. So we don't yet have a theory of everything. We have a theory of small things. That's the theory of quantum mechanics. We have a theory of gravity. That's general relativity, and they don't mesh, they don't mix. Maybe someday they will. But now we don't have a theory of everything. We can only go back to 10 to the minus 43 seconds after Big Bang. So how do our minds fit into the world? Some people view quantum mechanics as saying something about our minds in the world, but that's still open to interpretation. We don't know whether our minds rely on something more than the known laws of physics, or just a very complicated combination of atoms. And sometimes from a complicated combination of things, variety leads to something new emerging. Another amazing aspect of our universe is that it has these laws of nature. Why should there be anything regular at all? Why these laws and not other laws? And why is it that quantum mechanics can tell us, based on math equations, the chances of this happening, but it can't tell us exactly what will happen? So is it something about math? Wake up, computer. Is it something about math, or is it about the world? So this is a deep problem. A lot of people in their spiritual search will say, okay, math is kind of boring. I hated it in high school. I don't want to take along math on my ride to enlightenment. But if you really want to understand the world as modern science is revealing it, it appears to be a mathematical world, and we don't know why. So that's a great mystery to me. Two basic lessons of modern science. One of them might be called the Copernican principle, that we don't sit on a special place in the universe. Not all the things in the sky go around the Earth. In fact, we go around the sun. This may change with the next experiment, but we are finding that we are not the central aspects of the drama of the universe. There is a vast universe. There might even be extraterrestrials. We are not the only animal on Earth. Charles Darwin, evolution, the other animals are like us, but different. It seems like the fundamental principle of our universe is variety. Variety of life forms, variety of stars and galaxies. And one possible way to look at the ultimate law of quantum mechanics is that everything that can happen will. Everything spreads out into all possibilities. It's only that some possibilities act like waves that interact and dissipate. And that's why they cancel out, and we don't see everything possible happening. Now, this is sometimes called the many worlds interpretation of quantum mechanics. It's one way of looking at it. To me, this sort of solves a problem given by the philosopher Leibniz, who thought that God would never just say, well, I could make it this way or that way. No difference one way or the other, let me just choose it this way. Quantum mechanics does just seem to take random chance, but Leibniz called this the principle of sufficient reason. If all possibilities are taken at once, that would kind of explain why we seem to see things being mathematical and why quantum mechanics would be true. So at this point, I'll be open for questions. Thank you.